Hey, we are Team 14. My name is Jiayue. My group partner is Curtis. Our project is about real estate in Melbourne, adding value via machine learning. The presentation includes 3 parts. The first one is about domain. What is the background? How about the business value of it? What we have done to do the data processing, and about the EDA part. The third is about machine learning and what is the findings when we train the models, and which feature impacts the model most. Here is the business value. Whenever we come to a new city, finding a place to live is always the first problem needs to think about. What is the normal price of this type of house? Do the landlords or the property agents offer me a fair price? We are so confused about the price, whether it is fair or not, because we have no idea of the market, about the property market in that city. If we can input some important features like building area, the number of bedrooms, the location, and so forth, some system will just come out with the price of that house. It will pretty much solve the problem. We consider our project as real estate price prediction problem. So basically, to the business value, there are many 3 ones. Real estate analytics can be widely used by property investors and advisors. It helps understand how the overall market is performing in real estate. The model can be applied to predict property prices in other cities with similar features. The models can be adjustable and applicable to other cases. Let's look into the dataset. There are 20 attributes in the original dataset. I only choose some important ones to show here. Some attributes related to the location, such as suburb, address, the region name. Some attributes related to the property itself, like the type of property, the number of rooms, the land size. Some attributes related to the purchase of that house, such as the method of selling, the agent, who is the agent, and when was the day sold. Our target is to predict the price. The dataset is not clean. As you can see here, in terms of land size, there are plenty non-values. We remove them in order to have a cleaner dataset. Also, there are many outliers in terms of land size, distance, and the price. We only keep the middle 75% of the dataset. We were trying to make it distributed normalizedly. As I said before, there are some attributes like agents, the region name, the type of selling. So they are categorical values. We need to convert them into numeric data. We use label encoder to realize that. We can see here the larger building area is, the price is higher. They are correlated positively. It is pretty much the same as land size and price. Here is a heat map about all the attributes, how they correlated with each other. Finally, we come to machine learning models. We start to train them. We use 3 models here. The first one is multiple linear regression. Then is random forest. The third one is logistic regression. There are many attributes. They impact the price together. That's why we use the multiple linear regression instead of single linear regression. We firstly choose this combination of input attributes: the region name, the number of bedrooms, the method, the distance, the building area, the type, the bathroom, the car plot, the land size, and year sold. We also standardize these attributes. We set the test size as 30%, the training set as 70%. You can see here the result as multiple linear regression, the random forest, and logistics. It is quite obvious that random forest shows the best result. We look into the multiple linear regression and random forest. We try some more combinations of the attributes. We figure out that the distance attribute impacts the price most. Then follows the type of property, the number of rooms, bedroom, building area, land size, bathroom, car plot, year sold, and method. Since we've got this kind of finding, it helps the investor to decide which house to buy. If one house has a better distance but not very good building area, he should just choose that one because distance impacts the price most. After we done a lot of iteration of the training the models, we also find that the same attribute impact the models differently. For example, the method attribute negatively contribute to the multiple linear regression, while it contributes positively to the random forest, which means that when we remove the method attribute, the error will decrease in the multiple linear regression. When we add the attribute method, the random forest result will be better. Finally, we come out the best model, that is to use the random forest. The input attributes are region name, bedroom, method, distance, building area, bathroom, car, land size, and year sold. We also used the absolute mean error to evaluate the model's performance. Because we are to predict the price, we use the differences between the predicted price and actual price to evaluate the model's performance. It is not a classification problem. We can't simply use the accuracy to evaluate the model. Thanks to the machine learning, we can predict the price now in some way. There are two kinds of business model can be applied to earn money. One is that this kind of service can be used as public service to provided in official. It can attract more property investors to the city. It can also regulate the real estate market. If the service can be provided by the agents, it can be the customized service. They can use this kind of service to attract more customers and make themselves to be more professional in the property industry. That's all. Thank you.